Now that we understand average value and how integrals represent accumulation, we are ready for the main idea of this section. This is the Fundamental Theorem of Calculus Part 1. If small f of x is continuous on a closed interval from a to b, and we define a new function like this, big F of x equals the definite integral from a to x of small f of t dt. Then, the derivative of big F of x equals small f of x. This is a big idea. The derivative of an integral gives you back the original function. Let's translate what's happening. We start with a function f of t. Then we build a new function, big F of x, by taking the integral from a to x. Then we take the derivative on both sides to get f prime. So the derivative and the integral undo each other, and we end up with the original function small f of x. Now, what if the upper limit is not just x, but a function of x? If we defined big F of x equals the definite integral from a to g of x of small f of t dt, then we have to apply the chain rule. So the derivative becomes small f of g of x times g prime of x. Here's what's happening. You still evaluate the original function small f, but now you plug in g of x instead of just x, and then multiply by the derivative of g of x. Let's summarize the big idea. The derivative of an integral is the original function. This theorem connects differentiation and integration. Two really important ideas come out of this theorem are: a definite integral can define a new function. Every continuous function has an antiderivative. Now, let's apply this to example 2. We have big F of x equals the definite integral from 1 to square root of x of sine t dt. And we want to find the big F prime of x. First, recognize what we have. The lower limit is 1. The upper limit is square root of x, which is a function. So we must use the chain rule version of the theorem. So we use this formula, big F prime of x equals small f of g of x times g prime of x. Now let's identify each part. F of t is sine of t, and g of x is square root of x. Now I replace the function small f with sine. F of t equals sine of t. F of g of x equals sine of g of x. Now, g of x equals square root of x, so I replace g of x with square root of x. Next, I need to find g prime of x. In order to find g prime of x, I will rewrite square root of x as x to the 1/2. So g prime of x equals 1/2 x to the negative 1/2, which is 1 over 2 times square root of x. Now, I replace g prime of x with 1 over 2 times square root of x. So, big F prime of x equals sine of square root of x over 2 times square root of x.